Yes, guys. So again, I'm just furthering the topic. Okay, the Cartesian coordinates, Cartesian equations in case of volume of solids of revolution. So we were discussing about the topic volumes of solids of revolution. When we are forming a solid by revolution of an area, it forms a solid figure, and we have to find out the volume of that. Okay, that we discussed in the beginning. Okay, and the definition that how Cartesian equations are given, then what is the volume formula for the volume we have to apply. Okay, that we did. Okay, by taking some 13 questions in the previous lecture series, and again I've taken 12 questions for the furthering the same topic. There's some difficult questions I've taken here because students have asked me most of the questions which are difficult one or some easier one which I took in the previous lecture series. Now I'm taking the difficult level questions. Okay, so more questions based on Cartesian equations. Okay, so solids, volume of solids of revolution. I'm talking the same topic, furthering that topic by taking these questions. Now let me take questions one by one. I have given the definition that what is the solids of revolution and how it is formed and what the volume then and how the forms of, again I'll just make the figures of that time in these questions, and from the figures I'll just clarify that how volumes are calculated. So let me take question number 1 here. Again, find the volume of the solid obtained by revolving the loop of the curve this about the x-axis. So let me first find what the curve here given to us. The question is, the curve here is, it says that it forms a loop. Okay, now this is the equation a square by square equal to x square into, this is twice a minus x into x minus a. This is the equation of the curve here. About the x-axis, we have to revolve the loop about the x-axis and form a solid, and that solid's volume we have to find out. What kind of this figure is? Let me just show you some figure of this kind. Now in this case, if I substitute y equal to 0, suppose, then this whole equal to 0. So x equal to 0. From this x equal to 0, we will get x equal to 2a and x equal to a. What is the loop here? So first x equal to 0, the curve is meeting here. Okay, curve is passing through. This is 0, 0, at y equal to 0, x is also 0. Okay, and here the curve is having, this is a here, a point, and this is 2a point. X equal to 2a, this is a0, this point is, and this is 2a0. Now it says, find the volume of the solid obtained by revolving the loop of the curve this about the x-axis. Okay, so about the x-axis, this kind of loop. Let me take, this is the loop here. Okay, and again this loop is also forming this point. It is also passing through the origin this. Okay, so this kind of loop is there. But here we have to find out that this loop from limit a to 2a, this volume, I mean this is revolved around the axis of x, and this is y dash axis, x dash axis is origin O. From a to 2a only, it says, because this loop is the bigger one, it says this is not required. Or in this case, this loop is given to us. Now it says, find the volume of the solid obtained by revolving the loop of the curve this about x-axis. Okay, the curve is symmetric about the x-axis region. Now let me first talk about solution. Now in this case, the curve is symmetric about, the x-axis. Y-axis, the region is y is even powered, x is not even powered here. Okay, so here y is even powered. So y is even powered. So because of that, the curve is symmetric about x-axis. This kind of, I mean, just make the figure here. Okay, but this also there because the curve is also meeting the origin at 0, 0. X is 0 here, x equal to 2a, x equal to a. So x equal to a to 2a. Let me find out the area, volume of the solid. Okay, or we could take from 0 to 2a total, because if I take this 0 to 2a, that could also be taken. That is also the volume. But first let me find out a to 0, a to 2, sorry, 2a. Or if I take 0 to 2a, then this is also the loop. The two loops are formed. So this is meeting this kind of curve. Okay, there are 3 points here, 0, 0, a0 and 2a0, at which this curve is meeting. Okay, so this is the point here which we have to do. Now the so point is that what kind of this question is simple. So x equal to a to 2a we have to find out. So the curve is meeting the x-axis as a y, okay, x-axis at these points, okay, and loop extends from a to 2a. So a to 2a we have to just find out. Now therefore the volume of the solid obtained by, so therefore the volume of the solid generated by revolving or generated by revolution of the loop about. Now here I have to take, let me take, this is A point, this is B point, this is C point. So A, C, B, the loop is revolved around about the x-axis. So the volume will be a to 2a. This is x equal to here, okay, and x equal to, so this is, let me take here, this is dx here, this is p and q, oh sorry, p and q, this is m and n, this point is n here. Okay, so this elementary strip we have taken, and this elementary strip is forming this. So this is delta x here. So it will be pi into y square. This we have given the formula, that what is the volume of a, this is volume of the curve of this a solid obtained by revolving this loop about the axis of x. This is the volume here. What is y square? From this y square can be obtained. This y square equal to, and y square equal to, from the given equation, this is x square into twice a minus x into x minus a divided by a square. So this is the value of this y square. We can substitute this. This is a to twice a, pi I have taken outside. Okay, this is y square is nothing but x square, and 1 upon a square, let me take outside. This is y square here. So y square will be taken totally twice a minus x into x minus a into dx. Now this is to be integrated, but before that let me multiply them. This is just multiplication of the whole curve. Now let me multiply this and then integrate, and after integration we substitute the limits, and then the volume can be obtained. Okay, so this curve is here only a to twice a. Or if I take 0 to 2a, but this curve is under loop. So first loop is this is the bigger loop, a to 2a. Let me take that. So this is volume v is equal to, we are calculating, this is pi upon a square into a to 2a. This is x equal to, now x square into twice a minus x, let me first multiply. So it will be twice a x square minus x cube into x minus a into dx. Let me write it here. This is pi upon a square, a to 2a, okay, into twice ax square, this is twice a x square minus x cube into x minus a. Now let me multiply by x here. This is twice a x cube minus x4 by x, then by minus a, this is minus twice a square into x square, this is, and minus plus here, this is a into x cube into dx. This total multiplication now. This is x minus a. Okay, so by x, first by multiplying x, first by x, it will be twice a x cube minus x4 x cube into x. This is x raised power 3. Okay, so x4 minus, then by minus a, this is minus twice a twice a square into x square, and minus plus here plus a into x cube. This is the total algebraic function. Now let me integrate this and then substitute the limits. Then that will give us total volume. This volume is pi upon a square. Now first let me integrate them. Now this is direct integration. What is the total integration of this? This is first twice a x4 upon 4 minus x5 upon 5 minus twice a square into x cube upon 3 plus a into x4 upon 4, this value. Okay, this total. Now limits are a to 2a. So first of all, first 2a I have to substitute upper limit. What it will give us? Let me just check it. This pi upon a square. Here twice a into twice a whole 4. That means 16 into a4 upon 4 minus this is 2a whole 5. That means 32 into a5 upon 5 minus sign twice a square into twice a whole cube. Twice a whole cube means 8 a cube. Okay, twice a cube plus this plus, let me write here, plus a into x4 means 16 into a4 upon 4. This value is there. Then with lower limit minus a, sorry, this with the negative sign minus this, first will be negative, this is minus twice a into a4 upon 4 minus plus here this plus, because with negative sign lower limit it will be a5 upon 5, and this is minus sign, sorry, minus plus here twice a square into a cube upon 3, and this is plus. Okay, this is minus sign, this will be lower limit, so this is a into a4 means a5, let me take upon 4. Total values are these. And let me summarize them. Now a4, a raised power 5 is common throughout. A raised power 5, let me write here. So what will it give us? Volume V is equal to pi upon a5. Now into a raised power 5 I have taken common. Throughout it is common. Okay, so first will be, this is 32, 260 and 32, or 4 ja 16, 4 to ja 8, so 8 only is here. Only 8 is left in the first one because a5 we have taken common. Minus this is 32 upon 5, 32 upon 5 only. This is 16 upon minus sign, 16 upon 3 only. 16 upon 3. This is again 4 4 ja 16, so only plus 4. And this is 2 2 ja 4 here, so 1.2 with minus 1.2 plus 1.5. This one plus 2 upon 3 plus 2 upon 3 minus 1.4. This last one. Okay, so this is total value. Now let me take it further. So this is total numerical value. Let me solve them. So what we see here, 5 3, okay, 2 5. First is 4 plus 8 12, numerical value independent, that we will do. So this is, let me write, this is pi into a cube. Now it is a cube because, sorry, a square in the denominator. This is a square in the denominator, a pi upon a square only. But a5 we have taken out, so this will be a cube, pi a cube. Pi raised to a cube, this is 12 here. Minus, let me further summarize this. This is plus 1.5, this is minus 32. So this is minus 31 upon 5, This 5 we have taken out, and this is 32 minus 31 upon 5. Okay, then 16 upon 3 and plus 2 upon 3. This is minus 14 upon 3. This is minus 14 upon 3 plus 2 and minus 16, that means plus minus 14 upon 3. This 3 and this 3 cancelled out. Now minus 1 upon 4 and minus 1 upon 2. 4, if I take LCM, then minus 2 minus 1, this is minus 3. Minus 3 upon 4. These are the values. 4 and 8 I have taken 12. Okay, all values are added up. Now what is the LCM? Here we see. So here LCM is, if I take LCM, is the answer given? No answer given. Now let me take further. This is pi into AQ. Alright. Okay, 5 3 15. So just 60 is the LCM. If I take 16 as LCM, so that will be, let me take 16 LCM. Sorry, 60 LCM. I'm sorry. It is here 60. 60 is the LCM here, because 5 here 15 and 15 for the 60. Otherwise, because this is their prime number, 5 and 3 prime number, 4 is also prime to each other in this case. So this is 60 LCM. Now 60 into 12, 720, 12 6 are 72. Okay, so 720 minus sign, 5 into 12, 5 divided by this 12, 5 to 16. So 12 into 31 means 2, 1 carry, 12 3 36 and 1 37. Okay, so this is 372 with 31 into 12, right? This is 20, 3 divided by 60 divided by 3 is 20, 20 into this 14, so this will be minus, 14 to the 20, so 280, 20 into 14, minus sign here. Okay, now this is 15 4 ja 60, so 15 into 3, 45. Negative values are added up and subtracted from 720. So let me first add them, negative values. This 372, this 280, 45. 5 plus 2 7, 8 plus 4 12, 12 plus 7 19, 9 1 carry, 3 plus 5 2 5 and 1 6, 697. 720 now subtracted, 720 and 697 subtracted. It will be 10 minus 7 is 3, 1 carry here. Okay, so 11 minus 9 is 2. Okay, 2 and further 1 carry, 0, only 23. Positive 23 value is there. So let me first write what is this pi AQ. 720 minus 697 divided by 60. This is a second summarization, and pi AQ into 23 upon 60. Because 23 is the difference of this. Yeah, 23. So it can be written as 23 pi AQ upon 60 cubic unit. So this is the cubic unit volume of the solid thus generated. This solid generated by the loop. Okay, so this is the loop here. So final answer is this. This was the answer, 23 pi AQ upon 60. This is the volume of the figure obtained by revolving the loop around the x-axis, about the x-axis. Okay, so this is question number 1. Now let me talk about question number 2. Now question number 2, what does it say? It says a basin is formed by the revolution of the curve xq equal to 64 pi. Okay, about the y-axis, if I take, this is the basin, suppose a basin is formed like this. Okay, and from this point, this top is 8 inches. the depth of the basin is 8 inches. Okay, it says a basin is formed by revolving, this is y-axis here, y dash and x dash axis, this is origin O. So it says a basin is formed by revolution of the curve. Let me write the curve here. This is question number 2nd. Curve in this case is x cube equal to 64y, where y is positive, y greater than 0. Y is positive. About the y-axis, if the depth of the basin is 8 inches, it says depth of the basin is 8 inches. How many cubic inches of the water will it hold? The volume of this is to be calculated. Let me write here, this is A and A dash. Okay, now y will vary from 0 to this. And if I take, let me take, this is elementary step. If I take here P and this is Q. Okay, and this is delta y, the difference is, okay, the depth of this is delta y. Here, what is the, volume of this? So volume of this, we will take P coordinates is x and y, and this is x plus delta x, y plus delta y. So the elementary strips volume we have to find out first. So volume of the elementary strip and then limits. So here let me find the solution. Here we have to find out the volume of this basin, how much water will it hold, that means volume of the water. The volume of the whole basin we have to find out. Okay, now this is the basin which is having 8 inches, so volume will also be in cubic inches, okay, undoubtedly. So depth of the basin is 8 inches, it says. Now we have to find out that what is the, okay, curve is given to us, nothing else. Let me just find the volume. So volume of this water hold, so volume of the basin or water it holds, volume of the water it holds is given by, here 0 to 8, try to understand. Here y is equal to this, y equal to 0 to 8, because y coordinate on the origin is 0, because it is revolving around y axis. This basin is, this curve is revolving around y axis. Okay, so that is the point. Therefore y coordinate is, limits are 0 to 8, here it is 8. Okay, and this point can be written down here. And then the curve is this. So here the curve will be, volume will be given pi into x square into dy. Try to understand. Now in this case, this is x square into dy. Delta pi is this, and the x square or elementary strips volume. Okay, so this is x square into pi into x square into delta pi. When limits are used, and this is total volume of the basin we have to find out. Here we have x cube is equal to 64 by, no doubt. Therefore x equal to how much? Cube root of this whole. It will be 64 into y whole 1.3. That means x square, we have to find out x square here. X square is equal to, therefore 64 power 2 by 3. Try to understand. Into y is for 2 by 3. So this is what? This is nothing but 4. This is 4 cube. 64 means 4 cube. This is 2 by 3. Into y is for 2 by 3. It will be 16 because 4 cube can easily cancel out. Is 4 square, that means 16. It is 16 2 by 3 power. So x square equal to this 2 by 3 power. X square equal to therefore 2 by 3. Y is for 2 by 3. This whole 2 by 3. X square equal to whole 2 by 3. Or let me write here x equal to 64. Sorry. This is 64 y whole 1.3, and this is x square equal to 2 by 3. Now 2 by 3 is opened, 64 is for 2 by 3 into y is for 2 by 3. It is giving us 16 into y is for 2 by 3. Let me further solve it. So therefore, by limits are 0 to 8. Here pi, let me take outright sign of integration. Now f square is this. It is 16 into y raised to power 2 by 3 into dy. Simple. Now this is 16 into pi. Alright. Integration of y raised to power 2 by 3 is y raised to power 5 by, because 2 by 3 plus 1, that means 5 by 3 divided by 5 by 3. Limits are 0 to 8. Okay, is 16 pi into 3 by 5, this numerical value I have taken outside, into 8 raised power 5 by 3. 8 raised power 5 by 3. So this is nothing but, let me take 16 into 3, that means 48. Let me write it 48. 16 into 3 is 48 pi upon 5 into 8. 8 can be written as 2 raised power 3 raised power 5 by 3. 3 cancel out. 2 raised power 5. 2 raised power 5 is 32. This is 48 pi into 32 divided by 5. That will give us, now let me write here. So 48 into 32, 32 into 48, multiplying 8 to the 16, 6 1 carry, 8 here 12, sorry 8 here 24, 4 to the 8, 24 and 8 32, 32 1 33, 3 carry, 4 here 12 and 3, 15, 15 30, sorry 15 6, 36, it is 6 here, it is nothing but 15 36. So 15 36 into pi divided by 5. Now this is prime number because 5 is not divided by 5. We can write the answer here. The final answer is obtained as 15 36 pi divided by 5. This much cubic inches water it will hold. Cubic inches. This is the volume of the water which this basin will hold. 1536 pi upon 5. If pi we are not changing, pi may be 22.7, but it's not divided by 7, so we just leave it here. This is the answer here. Final answer 1536 pi upon 5. Cubic unit here, cubic inches. But water is height is in inches, the volume will also be in inches, cubic inches. Final answer is. This is question number 2. Now let me talk about question number 3. Okay, so question number 3. What does it say? So further we are discussing Cartesian equations when the volume is to be found out by the of a solid which is formed by a revolution of an area by an arc or within x-axis or y-axis and between two ordinates or between two axes. That is the point here. Now question number 3 that we talk about. Now find the volume of the area enclosed between the curve this and the x-axis and the parabola y is equal to 4ax. Alright, this says there are two curves here. Important question. The first curve is there are two curves here. Two curves. First curve is 27 into a into y square is equal to 4 into x minus 2a whole cube. Alright, this is first curve. Second curve is, this is first equation. Second is parabola. Now second says parabola y square equal to and y square equal to 4ax. Now this is the parabola. Okay, now what did it say about the x-axis? It says now find the volume of the area enclosed by the curve this and the x-axis, okay, and the parabola y square equal to 4ax. Now, so let me just first find the parabola. This is just a simple formula for parabola. Now, what is the parabola here? and where this curve will intersect, let me find out that. Sorry, this is a parabola shape. Now here let me take that this curve is intersecting, and from this point the curve is having this kind of shape. Let me take this curve intersect the parabola at this point. Okay, and and then this area is revolved around which area intersected between that area we have to find out. So what is that area? Let me just find out that how to find out this area. Now point is that this curve is having x equal to 2a. So at because when we substitute y equal to 0 in the curve given, y equal to 0, so x equal to 2a. So the curve meets the x-axis at 2a 0. This is the point 2a 0. Okay, and at the parabola where it meets, we have to solve these two equations. So solving y square equal to 4ax, if I substitute, then we have to solve it. Okay, then what is the solution of that? X equal to 8a it comes out to be. Okay, let me just, I will solve it. Here x equal to 8a. At this point, the curve meets at this point, x is equal to 8a. This point is 8a, and y coordinate will be, suppose y is there, y we will calculate from here. If I put here 8a here, so y square is 8 to 32, and 16 to 32, so 4 under root 2. Because 8a, if I substitute here, so y will be 4 under root 2. It is 4 under root 2 into a. So this is value of y, plus minus 4 under here also. This will be, so this is 8a and minus 4 under root 2a. This is value of y from this equation. How we have just calculated this? If I put x equal to 8a in this equation, 8x equal to 8a, can I get this equation? This is 4ax here. Now let me substitute here. This is 27. Let me solve these two equations. Okay, solution. Now let me find. Now this is the volume of the curve which we have to find out from 2a to 8a limits, and this curve is revolved around axis of x. It says this is axis of x. For origin, this is y dash and x dash. The point is that this curve meets the x-axis at point 2a 0. From this equation given, we see here that y square is even forward, y is even forward. The curve will